focus here, concentrate here, and sit attentive, chin up, and listen here, concentrate here. Now let me explain you what do you mean by positive series clipper without reference voltage. So listen here, let me give you a definition of that. Positive series clipper will remove positive portion of the input waveform without disturbing, without distorting another portion of the input waveform. That is called as positive series clipper without reference voltage. What I am telling? It's a clipper, it's a type of clipper which will remove positive portion. What is your portion? This is nothing but your positive portion. This will clipped off, this will deleted, this will removed. How? By without distorting. There should not be any disturbance to another portion of the input waveform. That is nothing but positive series clipper. Name itself suggesting you, the name itself suggesting you, positive series clipper. What it will do? It will remove positive portion of the input waveform. Clear? Understandable? Say so. Now, if you look the diagram, I have started drawing the diagram with negative end. What is this? Negative end means cathode. I am giving a hint. If it is a positive series, draw the diagram with negative. This is your cathode. This is your anode. Negative, positive, cathode, anode. Keep in mind like that. If it is a positive series, if it is a negative series clipper, what will you do? We will start with anode. We will start with anode. That clear. Clear? Now let me go to the operation. Somewhere in the double inverted column, now itself write down. If I ask a question from second unit, if you want to write the answer to the second unit after drawing the diagram, write down in double inverted column. My first case is what? For positive half cycle. What will happen for positive half cycle? Write down somewhere in double inverted column. For unit 2, we need to write the answers like this after drawing the diagram. Ardhamatunda? Clear? Understandable? Now look at here. For first positive half cycle, what is my first input? What is my input? Positive half cycle. Check here, apply here. What will happen? What will happen? Positive. This will go to negative. My first positive to the negative. Negative to the positive. Then diode is under? Diode is under reverse bias condition. Then how it will act? It will act as open switch. Switch is open. It does not conduct. Current does not flow. Then output will be 0. Your output is 0. Good. Your output will be 0. Now let me draw that. My input is positive half cycle. What is your output? Straight line. Good. 0. Up to here. Up to what? Up to pi. Here it is my positive half cycle up to a pi. This is 0. Make a thick line. Make a straight line like this. Thick line. Whatever, how much you want to make it for your better understanding purpose. Then you write down here what? D off. Why D off? D is under open condition. It is under reverse bias. Clear? Understandable? Now what is my second case? What is my second input? Negative half cycle. Now see here, this is negative half cycle. Focus here. My second case I am writing here. Second case negative half cycle. Negative to negative. Positive to positive. Then what will be your output? Forward bias. That will be under forward bias. It will act as a closed switch. It conducts. It is in on condition. Open switch means you just remove this. Make a. This is nothing but open switch. Whatever you will apply the input voltage here, that input will appear across output. If it is a closed switch, understandable? If it is a closed switch means I am applying a wire that input will be available across output. Then what is your output? What is your output? Input only. I'll tell you one more time. If it is under forward bias, it will act as a closed switch. You are applying a certain voltage here. That voltage will flow here, flow here. You will measure the voltage always across resistance. Output equal to input. If it is under reverse bias condition, it is what is that? Open switch. Means open means there is no current flows. If you apply a voltage also, that will not be available here because this wire is connection has been removed. The connection has been removed. You are applying any kind of voltage here, the connection is not there. I will switch on the button if the connection is loose, if the connection is not there. Whether the fan will run? No. That same thing. If the connection is open, your output will be zero. No current flows. Understandable? Clear? Say some.
Yes, sir.
I have not drawn the output. Now let me draw. What will draw here? For negative cycle? Negative only. Your input only. This. That is your output. Here you can write down D on. And this you mentioned as minus VM. Maximum voltage. So many times I said you, whenever you are answering whenever you are writing a answer for any question in the second unit, start with positive cycle, negative cycle. No need to by heart and apply those two concepts. What are those two concepts? TN mentioned as forward bias, reverse bias. Apply them as simple as it is. No, you won't by heart. If you understand, you won't by heart this. Only circuit diagram will become different. Only circuit diagram different. Clear? That is your output. Means what happened here? The positive portion has been removed. Say some. Positive portion has been removed. Here you can write down positive portion clipped off. Clipped off. Yes, listen here. So I have explained you the operation of positive series circuit with circuit diagram and input and output waveforms. So let me draw the transfer characteristics for positive series flipper without reference voltage. This part I didn't explain that there. So let me draw that. How we will draw this transfer characteristics? Based on those two equations, based on those two conditions. Listen here, focus here, chin up, sit attentively. Focus here, concentrate here. So we have two cases. If your input is less than or equal to 0, what is your output? For positive series flipper, your output is input only. For negative half cycle, Vin is less than or equal to 0 means it is negative half cycle. Your output will be input only. If your input is greater than 0, your output is 0 volt is mentioned as 0 only. This is the case. Means positive series flipper will remove positive portion of the input waveform. This is your input waveform, that is sinusoidal in nature. It is removing what? Positive portion, and you will have only negative portion. Say some, only positive portion will remove. So how will you draw this diagram? Transfer characteristics. What do you mean by transfer characteristics? Drawing a graph input versus output. Drawing a graph of input versus output. It may be a voltage or it may be a current. You are drawing a graph of input against output. That is nothing but transfer characteristics. Clear? Now based on this equation, these two cases, you can easily draw the diagram. Focus here. If your what is x-axis? Input voltage. What is on your x-axis? Input. Positive, negative. Y-axis? Output. This is negative. Now my first case is, if your input is 0, what is your output? 0. If your input is 1, 1 is that? If your input is greater, 1 is greater than 0, what is your output? 0, 2, 0, 3, 0, 4, 0. I have done with this. I have done with this condition, this case. So what you will do, you join these dotted lines. What? Join those dotted lines and make a thick line. It means your diode is in off condition. In this case, your diode is in off condition. And you write down here, clipped off. Understandable? In this case, your diode is in off condition and write down clipped off. The positive portion has been removed, has been clipped off. Now my second case. Now I will come here. If your input is less than or equal to 0. Now if your input is 0, what is your output? Input only. My input is 0, output is 0. If my input is minus 1, output minus 1. So here my input is minus 1, output minus 1. My input is minus 2, output minus 2. My input is minus 3, output minus 6. Like this. Minus 4, minus 1. So join these dotted line and combine this. So in this case, your diode is in on condition. Write down D on. On means conduct. Conduct. What is the spelling of conduct? C-O-N-D-U-C-T. In that I have on. So diode is in on condition. As simple as it is. Clear? So this is the transfer characteristics for positive series clipper without reference voltage. Understandable? As simple as it is, you need to put the values in these two cases. I have two cases. Put the values here. V is greater than 0 means 1, 2, 3, 4, 5. Check it. V will be 0. Now here it is 0, minus 1, minus 2, minus 3, minus 4, minus 1. That is nothing but less than 0. Your output is input only. Clear? So positive portion completely flipped off. 0, 0, 0. Negative portion, there is a waveform. Negative waveform. Understandable? Say some. Now I have explained you yesterday negative series clipper with reference. Some guys are having doubt. Let me draw the diagram and let me draw the input and output waveform and this transfer characteristics for negative series clipper with reference voltage. I will repeat it because some guys didn't understood. They queried me, though I have explained them. Let me revise it. Let me draw that. You understood with this? Any queries? Any doubts? As simple as it is. In these two cases, put the values, get the answer. Based on these cases only, you will draw this diagram. And don't by-heart that diagram. If you know these two cases, you can draw the diagram very easily. Just put the values, get the diagram, get the answer. Negative series clipper